All right, so we're going to walk through just how to do three-axis milling in Fusion 360. This will serve as a just brief tutorial on how to go through setting up stock for first op and second op, as well as adding a fixture in and then doing all the toolpaths. So first thing we're going to do here is we've got our part. This is a part we use in class. It's just a demo part taken from a textbook, so it's relatively boring, but this geometry is going to be kind of difficult for a couple different reasons. We've got an undercut feature here, which means we'll have to have a second operation. And we also have kind of a deep feature here. If we measure between this plane and the top of this line, we can see our distance, our minimum distance is actually 1.75 inches, which means we've got kind of a deep cut that needs to be made there. And it has to be done from this side to get that corner in there. So this will be a little bit tricky, but we can work with it. So first thing we want to do is figure out how we want to orient first operation. And now the kind of the default way to think would be, let's have this axis pointed upward. Let's have the part oriented like this in the mill. We can come down, machine almost 90% of the features, and then we just need to flip it over and get this undercut and cut off the remaining material. And that's a good thought. It's a great thought process. And the kind of the only issue with that is if we do that, our first operation will look like this with it when it's finished, right? And then we need to flip it over and get this green stock off the backside and get that undercut feature. And when we do that, what we're going to end up with is a couple different problems. We're going to have some trouble getting that feature fully defined because that is under the top surface of the vise, which means that when we go to machine it, when we go to do our surfacing operation, we're going to be colliding with the vise. And that is, to say the least, not ideal. Another thing is when we are doing this adaptive, the finishing operation, the roughing and the finishing operations on this piece, this is just hanging out of the vise. And so this is a good cantilevered surface. We're going to see a lot of chatter on that surface as the cutting forces attempt to pull material off there. So the better solution, in my opinion, would be to, okay, let's have our stock in the vise and let's do that undercut feature first. Let's get all of those features defined here. We'll rough, semi-rough, and then finish the flats and the non-planar surfaces. And then we'll flip it over once we get those undercut features made, and then we'll do the primary axis and get the rest of the features made. Okay, so if we go back to our part file here, the first thing I want to do is I want to position a machine vise in here. And we're going to position it for second operation. First operation isn't so critical. So I'm going to flip back over to the design tab. And I'm going to go into my data panel, and Fusion has some default work holding built into it. So when I go into cam samples, I can go into work holding here. And if you scroll down, there's a couple different just generic vise, generic three-jaw chuck. Any of these options are good options to put in our machine or in our part file here. So I want to be able to take this file and I want to save it into one of my own projects so that I can upload it to my cam file. So first thing I'm going to do is I'm going to save copy as, and then it will allow me to save the vise in my project folder. Okay, and I'm just going to save it in the IMSE curriculum folder. You could save it wherever you like, just so that you can come back and reference it. When I go back to my data panel and I go into the curriculum folder, I should be able to see that generic vise placed in my curriculum folder, and then I can just drag that in to my CAD/CAM file here. We're going to hit, let's move it out of the way here, just so we can see it a little bit better. I'm going to close this. All right. So got our vise in there, we've got our part. We need to position our part inside the vise. And remember, since we're doing the we're doing the bottom operation first, this face will be finished, and this face will be finished, and the bottom face will be finished after the first op. So we can grip on directly on the part faces. We don't necessarily need to model any stock, and we can place that in the vise. So first thing we're going to do is we need to change this joint here. So I'm going to double click on that, and that will allow me to position this jaw where I need it. I know this part is exactly 2 inches wide. If I click that edge, measure it, it's 2 inches. And so I just moved that vise jaw when I double clicked on that joint. I double clicked it and typed in 2 inches. Okay, so now that's fully in there. I want to create a joint to position our part within the vise. Luckily, they've already included joint origins, so it should be just a matter of I create a joint between our vise. I'm going to pick this joint origin right here, and then when I go down to my part, I also want to pick a joint origin that will be on that surface. So I can pick this face here, and if I hold down the control button, it will lock onto that face, and then I can go ahead and move my cursor towards the center of this hole. Okay. It's going to reposition our part, and we can move it down a little bit in the vise jaw to have it hold a little bit better. Right now it's not actually in the vise jaw. So I'm going to move it down in Z. Sorry, move the jaws up in Z, and let's move it 3/8 of an inch, 0.175. That should give us enough room to hold on to while still allowing us to do our finish machining. And when I hit enter, it's going to reposition all of the joints, all of our fixture to where it needs to be. Okay, so there's our part in our fixture for second op. That's all good. We can see that the vise wasn't totally constrained. You just got a part of the lead screw for that jaw hang, or for the vise hanging out here, but that's okay. Not necessarily crucial. All right, so let's start process planning here. Let's start our toolpaths. So if I go back to the manufacturer space, I can start building our setups. Now, our first setup here is going to be that underside, and we want to create our stock just for the model at hand. We can see it's trying to model stock for both the vise and the nut on the vise, but we don't need to do that. We're just going to pick our model, and we can see it's automatically generating our stock there. For fixture, we're not going to model it for first operation. Like I said, we should have plenty of room to hold on to the material in our vise without having to model it. And just for clarity here, I'm going to actually hide this vise. That'll make things a little bit easier. So when I go to the stock, I know I'm going to use nominal size stock. Okay, so our part is 3.5 inches wide, 2 inches deep, and then 2 inches tall. So I'm going to choose stock that's, let's do 5 inches, 2 inches, and then 3 inches. And that's way more stock than we're going to end up needing, but that is the stock that we're using for our projects. So we use that just for demonstration purposes in this software. Realistically, you're going to want smaller stock. So with our setup in there, we notice that it's oriented incorrectly, so we got to change that. And we also want to change where our work coordinate system is. So if we go to our work coordinate system here, we can select our orientation and the point at which it's located. If I go into orientation, I can select my z-axis plane. I can change it from the original model orientation. So I'm going to flip it upside down. I'm going to pick this surface, or that plane, as my z-axis. And then I'm going to choose this axis as my x-axis. And you can have that pointed either way. Since I already have it oriented like this, I will have the x-axis pointed this way. And then for our actual work coordinate system, our origin, we can pick any point on the stock box model. You could also select model box, and then it will use the bounding box on the model. You could also just select a point on the model as well. This is great if you have a sketch on the model where the point that you're trying to locate doesn't exist in space, but you know you can edge find that to be your work coordinate system. But we'll just pick our stock box point, and we'll plan on using an edge finder. So we can access this face, this front face, this left face, as well as the top face of the stock pretty easily here. Okay, so when I hit OK, there's our part in space in stock. So we are ready to get to machining, and the primary material that we want to remove here, we don't need to go all the way down. In fact, it'd probably be best if we just roughed out to that surface, maybe a little bit below, because that's where we will be holding on to. So first thing we're going to do here is add some roughing operations in. And so you can do roughing operations a number of ways. You can do a 2D adaptive clearing. This is a totally reasonable toolpath. You just need to select a tool and then define what geometries you're going to be machining. And then you can do your machining. For this, we'll use the tools provided for the class for the semester project. I'll throw a bullnose end mill in there. Bullnose end mills are good. You can see you can see my window's a little bit large here, so let me shrink it down. Okay, so I can select that tool. We'll use aluminum feeds and speeds. You can see our cutting data down here. When I select that, it pulls that tool in. We can see I've got my geometries, our heights. We're going to go down to that surface. And all of these should be okay. I'm going to change our stock to leave to about 10 thou, just so we don't have as much material to remove on our finishing pass. Okay. Our optimal load should be driven by our tool step over. So if you edit the expression, you can see where it's getting that number, and you can change that as needed. Like if you wanted to take lighter passes or decrease your chip load or whatever you needed. So we can see that 2D adaptive is okay, but it's not really looking at the full 3 dimensions of our stock here. And so I'm going to get rid of that. And instead, I'm going to do a 3D adaptive clearing. And so what I'm going to do is I'm going to pull that tool in, that same tool that we were just using, our bullnose end mill, aluminum. And now this operation will look at our stock and our geometry and do most of the work for us. So we have rest machining turned on, so it will look at our original stock and then machine the material that exists in the stock that's not in our final model. Notice we don't have to highlight any contours or anything. It will automatically recognize what material needs to be machined. But if you did have a special machining boundary, say you were trying to avoid fixtures or vice jaws, for example, you could specify specific boundaries to stay within. For our heights here, by default, it goes to the bottom of the model. We don't need to go that deep. I'm just going to pick this plane right there. And I like to go just a little bit down. So let's go maybe 20 thou past that plane. That should be more than fine. And actually, when I think about it, I actually need to go all the way down into this pocket. So I'm going to modify this just a little bit. I'm going to pick this plane right here. It's actually the same plane. And then let's go 20 thou lower. Or sorry, 200 thou, maybe 250 thou, a quarter inch. That looks good. That should get us to the bottom of our little trough there. And I realized I made a mistake. I need to go in and decrease my stock to leave here. So if I go into passes, I can decrease my radial stock to leave. Our optimal load, of course, is going to be driven by our tool step over. Our maximum step down is going to be driven by our tool step down. These are all parameters that I specified in the tool library. So these should line up with our feeds and speeds that we selected for this tool. So when I hit that OK, it should generate our operation here. We can see it's coming down, it's machining out that stock, and it's doing what's called a trochoidal toolpath. It is just machining as much material as quickly as possible while trying to maintain constant chip load on the tool. It's also doing that trochoidal path inside this groove here. That's okay, we can work with that. It isn't going as far down in the groove as we need. You can see that there's still a spot in the middle here where if we try to surface that right now, we're still going to have quite a bit of material that our ball mill has to take out. And so we're going to make our lives a little bit easier, make the life a little bit easier on our ball mill. And we're going to duplicate this operation, or duplicate this tool path, but with a 1/4 inch tool. So when I go in and I hit edit, on that duplicated operation, I can go back into our tool library here, the S24, and I'm going to pick our 1/4 inch end mill with the corner radius on it. You could use a flat, that's also fine. And aluminum feeds and speeds. I select that, and notice that all of our parameters that we typed in before are still there for the face, because we duplicated that operation. So all of the things that we changed should remain the same. The values that were driven by the tool have now changed in here also. So before, our 1/2 inch tool could take a 100 thou width of cut. Our 1/4 inch can't take that big of a cut at the feeds and speeds we're running. And so it's automatically pulling in that step over from our tool, which is the nice thing about parameterized operations. So when I hit OK, it will be doing the same type of thing. You can see we're doing a big plunge operation there, a big ramping operation. We can eliminate that or reduce it quite a bit. We don't necessarily need that. And it is going down all the way into that groove because the diameter of the tool is significantly smaller. So that looks great. I'm pretty happy with that. I do want to change this ramping parameter though. And you can see rest material adjustment reduced to maximum limit. Okay, that's fine. One of the things I also want to note here is that it's not creating all of the operations to remove all of the original stock material. It's only removing the material that was left over by our 1/2 inch end mill. And it's kind of magic how this does it, but Fusion is pretty intelligent, especially the adaptive clearing operation. If we go in and we edit, we can look at our geometry. And when I said we have that rest machining turned on, this is sort of the brains of it. This will increase the computational time of generating the toolpaths, but for what we're doing, not a huge deal. What it's doing is it's looking at that previous operation and it's saying, okay, I've already machined this. I don't need to do all this air cutting again. And so when I click OK, we notice that it's not generating out all of that stock. It's not generating the toolpaths to machine out all of that stock. And so if we turn that off, you can see, for example, now it's going to generate all of the operations to start, assuming we didn't machine from stock. Yeah, there we go. So that's just something to be aware of. So we'll turn rest machining back on. It'll take just a second to generate, and we actually do want to remove the ramping operations in here, or at least reduce them. If we go to our heights, our retract height here is from the top of the stock plus 0.2 or 200 thou. We can reduce that. I'm going to pick this face. Because we've already machined out most of that material, we can do maybe, let's do 100 thou above there. And our top height here we can also reduce. So we're going to just have this at the top of the model. That's fine. We go over to linking where our ramping parameters are. We can reduce the ramp clearance height. Let's just reduce it to 50 thou. And we could change our helix diameter if it wasn't fitting into that hole. But for now it looks good. I'm not going to change anything. If you have bores that your tool should be fitting in but isn't, you can reduce your helical ramp diameter and your minimum ramp diameter. And that will sort of encourage Fusion to generate the tool paths to ramp into the hole to rough it out. So when I generate this tool path, we can see, there we go. Now it's ramping farther than we need it to, but that's okay. I'm not too worried about that. It is going to be cutting at full flute length, but it's going to be doing it sequentially as we ramp down. And if we were really trying to optimize this for production, we could say don't do cavities here in passes. We could turn off machine cavities. We could then duplicate it, edit. We will click machine cavities, and we could specify, go down to that bottom face. We look at our heights in the model. I just want you to go to that face, maybe a little bit further down, 20 thou. And then I want to turn off rest machining, and I do want to turn on a machining boundary. So I'm going to make a selection. I want to stay inside that boundary and inside this boundary. So when I click OK, it should generate our ramping operation just to go past where we need it to be machining. So that will save us a couple minutes here. Again, if you're prototyping and you're just making low volume parts, not going to make a huge difference. But for production, if you're making 1,000 of these, you just save 2,000 minutes. So it may make sense depending on your use case. All right, so it looks like most of our roughing stuff is done, and we can start looking at our floor finishing as well as our surface finishing and our walls. So for our finishing operations, the first thing we need to do is finish this outside contour as well as finish these flat faces on the top of the part. So what I'm going to do is, usually when we're doing a contour finishing operation, I prefer to use 2D contour. And we're going to use just about the biggest tool that we can fit in the in this setup, so we have the most rigidity. Ideally, we'd be using a different tool so that we'd have an end mill for roughing and an end mill for finishing. For this instance, I'm not too picky. I'm just going to use that 1/2-inch end mill that we used for the first op, for the first setup, excuse me, the first roughing operation, and I am going to pick the finish cutting parameters. And when I hit select, we'll pull that in with all our cutting data. It is just generating, those tool passages are at about half of the chip load, the feed per tooth, as the roughing operation. So that's the only real difference there. I'm going to generate a silhouette for our part, so it will do the finishing operations. And we can see here that it's going to do our finishing. I only want it to do the outer loop for now. So I'm going to select outer loop. Okay. And for the height, by default, 2D contour says, okay, we're going to be doing it at the height of that contour, which is, in our part, at the top. But in actuality, I want it to do that 2D contour on to the bottom of this face, or at least just this 1/4-inch section that we'll be gripping on for the second op. So when I select that, it'll place our bottom height at that plane, and I'm going to reduce the height on that to 20 thou below that. We do have a corner radius on our tool, so And actually, let's do 40 thou just to be thorough. And we can see when we do our cutting up here, that looks good. It's cutting just a thin piece of material off the wall. We're not taking too big of passes, and we are running at a finished feed rate, so that should be really good for us. We do need to finish the inside of these bores, and we can do that similar to how we did the roughing stuff. We're going to duplicate this operation here, except now we're going to be using our 1/4 inch tool. So I go into our setup, or our tool library for the setup. I'm going to pick that roughing tool that we use, the 1/4 inch, and I will pick the finishing cuts for that. Now I'm going to go into my geometry here. We had to do our outer silhouette. This time we wanted to do the inner silhouette. So just our inner loops. For our heights, we want it to go down about 40 thou because we do have a radius on our tool. It should be noted here that that radius, or that height that we picked, is actually a little bit lower than where we roughed out. And so when you bring the tool in to do that finishing operation, it's going to plunge into material. And we don't really want that. Our end mill won't like it. Our part's not going to like it. So I'm actually going to modify our roughing operation just to make it bore down a little bit further. So we had gone down to that bottom face minus 20 thou. Let's go down to 60 thou. And the reason I'm doing that is because we are leaving stock to leave on the bottom. So there we go. It roughs out just past where we needed it. And then our finishing up comes in, interpolates that circle, and then we're all good. All right, now we need to finish off the floors. This should be fairly easy. If you go into 3D, there is a flat operation that Autodesk has created, and this is similar to adaptive clearing in that it's intelligent. It's going to look at your model and make decisions. We could do this with the 1/4 inch, but to maximize our efficiency, we'll do it with the 1/2 inch. We'll run finishing speeds for that, and it's going to automatically recognize flat surfaces. We shouldn't need to change much. We could change our step over here. Because we're only taking 10 thou off, realistically we could take full width passes, so 1/2 inch wide passes. I like to do like 3/4 just so that I know we don't have a cusp. So I'm going to type in tool diameter, and then I'm going to multiply by 3/4, 0.75. And so our result is there. If we hit OK, it uploads. Perfect. When I hit OK, it'll generate our toolpaths on the top here. Great. So there is our flat operation. And if it was doing faces that you didn't want it to do, you could modify that in the geometry tab. The order of our tooling is a little bit messed up here. That's okay. We can optimize this for tool changes. I'm just going to move this up to where we had the previous 1/2 inch tool, our tool 13, just so they're grouped together. This is just going to minimize the number of tool changes. Not a big deal, but again, if you're in a production environment, it will save you time. So we've got our finishing for the floors and the walls. The next thing is doing this inner surface here. And so this is what's called the surfacing operation, a 3D surface. And so we can do any number of toolpaths for this. Parallel toolpaths are a great option. They're just going to take the tool back and forth across the surface, and you can specify direction. Scallop, contour, ramp, any of these are good. They all have their own specific use cases, but you can kind of pick and choose what you want to use. There are multiple toolpaths will work for multiple operations here. I usually default to steep and shallow. And let's see how that does on our part. So I'm going to go in to our tool library here. And I know that our 1/4 inch, our 1/2 inch tool, if we chose a 1/2 inch ball mill, that may be a little bit large Where is that? Oh, sorry, I have a 3/8 ball mill. That might be a little bit large. We'll see. The other option I have in here is an 1/8 inch, and that's just too small for what we're trying to do. So we will use the 3/8. We do have finished feed rates. Note I don't have a roughing feed rate in here. You shouldn't be roughing with a ball end mill. These are special tools. We only use them for for finishing operations, not for roughing. So when I hit select, it will allow us to, uh, it will pull in that tool with all the feeds and speeds. If we just hit OK right now, it will generate a toolpath. It'll generate more toolpath than what we needed, right? We don't need to machine those faces. Those faces are already machined. We do need to machine that groove. So when I hit edit, I want to limit it to that surface right there. And now you can do that with a machining boundary, and in fact it's doing that automatically. We could select this boundary right here. I mean, we could do a number of selections, try to get that face. But in fact, I kind of like a little secret here that I think is kind of hidden. First, we need to turn on contact point boundary. You can read into that, but it just allows our tool to go past the boundary if it's still contacting the part. And for a ball mill, that's what we want. The avoid machine surfaces, that is kind of the hidden trick that I really like in Fusion. We can specify surfaces we don't want it to machine, but even better, we can specify only the surfaces that we want it to machine. So if I select that surface, it will now only machine that surface, which is exciting. You may also notice there is an option in the geometry tab to exclude flat faces, and that effectively should do the same thing. It just eliminates the faces that we have already machined, and it's trying to do the surfaces on the outside of the part because we have contact point boundary on. So I guess we don't really need that. So I'm going to go back here, and I like the machine surfaces. Like I said, we've already done the contour around the outside. We've already done the flat surfaces. Now it's just a matter of getting that surface machined. Our step over for the steep passes is pretty small. We're only going to get 5/10 cusps, which are fine. Same thing with our step over on the shallow passes. We're only going to get a 4/10 cusp, excuse me. So that's not a big deal. We're going to hit OK. And we can see we get a nice toolpath here. If we look at our in-process stock, we don't have much for cusps, and that's perfectly fine. If you needed to get a better surface finish, you could decrease that step over. If you wanted it to be faster, you could increase that step over. It's suited to whatever your engineering requirements are for the part. The last thing I like to do is to create a deburring operation. You can do that to just add a chamfer under our part. You can do that with a 2D contour. So with our ball end mill selected, we can select chamfer. And when I select that, I can pick individual contours that I want it to chamfer. And it will automatically generate toolpaths for that. Now these chamfers are a little bit wide, so we could go back in and we could change that chamfer width. Yeah, 46 thou, that is simply too much. We're just going to change that to, not even that, let's do 8 thou. That's a lot better. We just want to take off that sharp edge. We don't want to actually add a chamfer. Okay, so that looks good. That's one way to do it. One of the other things you can do is Fusion 360 in the last year added a deburring operation. And so if you select deburr, this is an intelligent operation. You don't even need to select contours. If you hit OK, it will automatically generate your deburrs, your deburring operation. And you can specify heights that you want to limit it. One of the things I caution is it will do vertical chamfers, which is great, but oftentimes it will plunge into material. And so watch out for that if you're doing a deburring operation. But this looks pretty solid. It's not plunging into stock per se. It shouldn't be plunging into the vise. So this looks pretty good. I'm pretty happy with this. So the last big thing I want to do is I do want to simulate this operation. If I go right click on it and I click simulate, it will bring me into the simulation window. Uh, you can have your stock colored a number of different ways. Let me move this up here so you can see it. I usually like to work with comparison. This just allows me to see what material is left, what material haven't I gotten yet, and it's a good dummy check to see if we're over machining or under machining in some areas within the tolerance that we specify. So when I start the simulation, I'm gonna change my viewpoint here. We'll stay fixed on the model, and we can see it's doing its roughing operation. We can speed up. We're just going to walk through and look for troublesome toolpaths. We can see it did that slot. It might have problems clearing out chips out of that slot, especially if we're using like a 4-flute, a 5-flute, a 6-flute end mill. But I believe we're using a 2-flute end mill, so I'm not too concerned. Even so, if we really wanted to, we could decrease our maximum step down or decrease our step over. I'm thinking it's going to be okay. We will find out. So it's also going to come in with our 1/4-inch tool and do the roughing operation. It's doing that big slot in the middle. There are more efficient ways to do this slot. Don't get me wrong here. This is what Fusion thinks is an efficient operation, but you could do some full slotting, some shallow slotting passes, and get this done in just a couple passes. To me, it's not worth my time right now to do that. But again, if you are in a production environment, you would want to do some slotting operations. Okay, I'm going to turn off my toolpaths here so we can see our geometry better. Okay, I'm going to speed this up a little bit. We can walk through, and in fact, we can skip operations as well. It's doing our ramping. There it's doing our finishing operation. Now it's going to do our floors. Great. Now it's doing those inners, and here is all of our surfacing. If we wanted to, we could limit the rapid travels and just have it do back and forth, back and forth. And in fact, the parallel operation will save you some time if you do back and forth. But this is okay. I'm pretty happy with this. We can see there wasn't a chamfer design on our part, so it thinks that we are removing more material than we needed to. That's okay. Doesn't hurt my feelings. And that looks pretty good. We have these nice faces here that we can grab onto with our vise. And we shouldn't have any interferences with the second operation here. So next step is going to second op and doing all the machining in that operation.